This computer. Okay, welcome everyone. So my name is Vincent Chiu. I'm the Education Director for ISC2 Alberta chapter. So first of all, the land acknowledgement. We would like to acknowledge that the Calgary is in the Territory 7. So basically originating with the Blackfoot, extend all the way to Tony Dakota, to Sina Nation. And we're also in the District 5 and 6 of the Métis Nation. Any one of you online or anyone here present from another territory or district would like to acknowledge? No? Okay. So in that case, yeah, without any, yeah, let me, sorry, I have to, yeah, I don't have the, I was going to introduce our speaker here, and right, I don't have the, yeah, so too many things open all at once. Okay. First of all, I'd like to introduce Ian Verhappen. So Ian is his presentation today is on operational technology, OT Security 101. So the abstract is microprocessor-based system are everywhere, including industrial processors and associated operating technology environment. So much of the core technology used in the OT environment are the same as the one used in consumer business IT environment and result in common assumption. It's the same tools and protection methods are also transferable. Unfortunately, this is not the case as each environment has different requirements and demands. So this presentation will summarize some of the main differences in the approach, alternative ways to address these differences, plus several international standard development and related industrial recognized approaches to implement best practices to protect OT system and associate critical infrastructure. So Mr. Ian Verhappen, P.Eng, he's a manager of security and functional safety at Willow Glen. Since the 1980s, he has been involved in all aspects of automation in the industry. He is a designated certified automation professional and a professional engineer in 3 provinces. He's a recognized ISA fellow and a member of Automation Hall of Fame for his contribution to industrial automation in industrial field network. And Ian is actively involved in the development of standard, including the chairing CSA P125. I'll let him explain all those numbers and what they are. Responsible for adoption of ISO and IEC, cybersecurity standard in Canada, and an expert on several IEC 62443, which is cybersecurity for industrial automation standard, as well as managing director and convener, is that? Convener, yeah, for the development of the intelligent device management standard. He served as a member of ISA standards and practices board, a member of IEC Standards Management Board, and is also an international chairperson of IEC-SC 65C Industrial Network that oversees all field bus protocols. Furthermore, Ian is a regular columnist for automation trade journals, a conference presenter on a variety of automation topics, and co-auditor of ISA Automation Book of Knowledge. Let us welcome Ian.
Thank you.
Okay,
Okay, well, thanks, Vincent, and thank you everyone for joining us this evening. I know it's one of the last nice days of fall, but thanks for joining us. So as Vincent said, we're going to talk about where is it? Oh, I'll go here. We're going to talk about several things here. Now mine's frozen. There we go. So I had following topics, right? Basically, Vincent in the introduction talked about IT-OT convergence. And so let's start with why. There's always a why, right? And then we'll take a quick look at some cybersecurity standards and regulations. And we'll talk about 62443, which is kind of the de facto OT security standard. Of course, It's standard, but it's actually, as you'll see, a whole bunch of them. We'll do what Vincent, and then we'll look at what's the difference between OT and IT. After telling you how we're all the same, we're going to tell you how we're different. And then we'll just wrap it up, and of course, Q&A. But if you have questions anytime, just when you're here, raise your hand, pipe up. If you're online, just send a chat to Vincent and he'll interrupt. Okay. Oh, what happened? What happened to my graphic?
Oh, it's animation. So you press down the next. Okay.
Yes. Okay. So so why did innovation happen? Right. Basically, we need to figure out what's going on, and innovation only happens when it becomes practical and cost effective, right? Because there always has to be a return. You know, I had the pleasure of knowing Dick Morley, the guy that invented the PLC, and he came to visit us a couple of times. And you know, he was also an angel investor, and he said, you know, the engineers are always full of great ideas, right? I know my wife's always chewing me out. What are you doing? Oh, I thought of something really great. So right now, then they can always find money, right? You can always find people that are willing to invest. But Dick said, anytime someone would come to them for an answer, the first person they looked for was, who do you got to do the marketing? To tell you that I might have the best mousetrap in the world, but if only the three of us in the room know it, you'll sell three, right? And so then when it happens, right, something's changed. So in order for innovation, we need something to change. And so the key innovation drivers across every generation of operational technology. And, you know, this goes back to arguably 100 years ago, pre-OT, right? When we first were talking about pneumatics. Why do we use pneumatics, right? Because they were looking at because air was easy to move. It was in a refinery, explosion proof. Air doesn't blow up. That's why they use pneumatics. Problem with pneumatics, you have to keep everything close together. Great thing about pneumatics, going way off topic, but great thing about pneumatics was when we brought in field bus networks and we're doing control in the field, because pneumatics needed to keep things on the same airline, if you were doing the actuator and the sensor, well, for field bus, in order to do control, you had to do the same thing. So I always telling everybody, if you have a really old refinery that you want to upgrade your instruments, just run your wires through your instrument tubing and you'll have the perfect way to run your network. But of course, that was kind of facetious. But the main thing that we're doing, right, you want to walk in, at least in the operational environment, and arguably in IT, right, we want to maximize system reliability. That's for anything, right? And then the next one is, because this affects profits for commercial operations, right? It also affects user satisfaction. So Willow Glen does a lot of our work in Metro Rail, and you know, if I dropped my car off on Monday, right, and there was the incident down in Kensington, and so the C train was, and you're going, so then all the connections missed, right? Same thing. But the same thing, satisfaction is important for pipelines. We also work in pipelines, and so the key thing for pipelines is reliability of supply. It's not only getting it from there to B, A to B on a pipeline, but it's also, if I want to be able to put in my 10,000 barrels of oil, you have to guarantee that that pipeline is open. It has that 10,000 barrels of oil. So this is kind of all showing where reliability comes in. Of course, minimizing operational costs, right? That's a key thing. Minimizing capital costs. Well, these two are opposites, right? I think some of you that might have heard me talk about this before, but so when you're doing a new project, what's the goal of the project manager? They want to finish it as soon as possible, as cheap as possible. What do the operating people want? They want it to run as long as possible for as little money. Well, in order to make it run as long as possible, you're going to have to spend some capital. And unfortunately, there's not a lot of people that look at the life cycle to do the both. And I've been on both sides, right? I've been in the pendulum always goes, right? I've been at places where they were gold plating to minimize operating costs because the operators, they had the hammer. I've been the other way, right? Where it was put together with baling wire and spit. And, you know, as soon as there's always the joke, right? As soon as we get it turned over from the projects team, we'll start spending all the capital expense budget to make it work the way it should. So, and minimizing risk. All of us working with cybersecurity are very familiar with risk, right? It's really all about managing risk. And actually managing these two comes to managing risk as well. Okay, and growth. What new opportunities, new markets can I get into, right? What new ideas or ways can I do to get revenue? And then this one is, I argue, the weakest one, competitive pressures, is Vince has one, you know, and I'm his competitor, so I need to have one too. And for a while, there was people that, you know, trade shows, when trade shows were still kind of a big thing, they said, well, all our competitors are there, so we have to be there too. Once they realized that that wasn't necessarily true, what's happened to a lot of trade shows, right? So just one example. So let's summarize all this over different generations of control system. And you'll see that a lot of these will parallel computing. Well, maybe not, but yeah, there is, right? This is the mega, right? Fill the room with a computer day, right? Now we start getting them into a small enough size, right? Third gen, we're starting with PCs, right? In here, PC area. Now we start getting servers and the internet. Oh, if you ever go to Geneva, you have to go, there's a tram right from the train station, takes you out to CERN. So everybody knows CERN is the big collider. You can get tours, like 6 people a day, but it's almost impossible. But there is a little museum right there. And in that museum is the very first web server. And they have it sitting there under a case. Geek and me, right? So anyway, and then now we're getting into the 5th generation, which is adaptable. So in the case of SCADA, right, we were talking about radio modems. Basically think of this as serial communications, right? So we went from serial, now we started using LAN and WAN, right? First generation of 802, right? With coax cable and all that good stuff. I see nodding his head. He's older than me, look.
I know token ring, so.
Token ring, yeah, exactly. And then we start getting to standard protocols, right? Now IEEE really comes out with the 802.11, start going crazy, right? The internet, and now here we are. You know, how many of you have heard the latest ads from Rogers about, well, we got you covered with satellite, right? With their new, you know what? Everybody's going to have that because that's part of 6G. 6G is seamless integration of low LEO satellites and ground-based systems. So good marketing, but anyway. So we look at it, right? They needed network communications, centralized monitoring. Again, centralized monitoring, but now we're starting to get more data and the operator starts to be able to interact. And now today, right, the expectation is virtualization. So in the OT environment today, like this side of the page looks pretty similar. Looks just like all of you, right? You've got your seeing, XDR, SOAR, whatever you want now, right? Got your logs coming in. You got your logs and reports going out to the people. Some sort of an interface, right? You collect your data from different places. The thing is, and then you have your control center. So right now, there's the IT predominantly and OT. they're all running on servers, right? Predominantly these days, Linux, right? With whatever the latest version of the Red Hat or similar. But we have all the same tools. The core is MITRE. Yeah, the MITRE reports now are coming in with this thing called Styx Taxi. It's an open JSON-based protocol to exchange data back and forth. And so, so that's a real enabler. And that's actually, that's what we at Willowglen are doing to bring our data in and contextualize it to the operators. By and large, you know, we have the experience that in most cases, what happens if there's a cyber incident, as in the Colonial Pipeline is the latest big one, what do? They shut everything down. Well, that's kind of the, I won't be kind, I'll say that's the IT reaction, right? We isolate you. And as we'll talk about a little later, that's not the right answer for OT. Yes, you can isolate, but it's got to be focused. Because if I shut everything down, it's really hard to start it up. It's big bucks in a hurry, right? So part of what this specificity that we can do with this now allows you to say, oh, well, we have a report from one of these sources that this type of controller is susceptible. Okay. So now if that controller, I can isolate that controller. And a lot of times, if it's a piece of really critical equipment, I'll have 2 or 3 of them. So then I can isolate one and keep running my plant with really no impact. Or if it's a pipeline, quite often you can run a pipeline at lower capacity, right? Because you won't have as much pressure from a pump. If you have to shut down a full station, you can usually skip a station and still get your fluids through the next station. So what are the standards, right? We talked about standards. All the IT people, right? They know 27,000. It's the base security, so certifications available, and zero trust is kind of the next step. I don't know how many of you probably very few of you. I write a column every month for Control Magazine. And I wrote recently that I really think that, as we'll talk about a little later, 62443 uses a concept of zones and conduits. So a zone, right, and zero trust are kind of the same. A zone means all these things are kind of together, they have to work together. And so I put them in a basically a virtual network, right? So it's a VLAN, and you can, right? I argue that a zone, like zero trust, is reliability of one. So if you make a zone of one thing, then you've got zero trust, right? So the concepts are the same, okay? So 62443 will show you in a minute. And then, of course, there's the NIST standards. And this one is especially for OT. I've got references in the very last, at the end of the presentation. So when, you know, if you want the presentation, let Vincent know, let me know, we'll send it to you as a PDF, and you'll get the links for all these references at the end.
Yeah, you guys did receive the contact, Ian's contact. Feel free to contact him directly.
Yeah.
If you have any additional question, if you want the slide, yeah, contact him directly.
Perfect. Okay, oh, did I hit 2? Cool. Nope. Okay.
Yeah.
So we're going to now compare NIST, right? The NIST cybersecurity framework, right? It was only released a year and a half ago now, right? And it's become sort of the norm. It's analogous to the Plan, Do, Check, Act, right? So the continuous improvement cycle. And so basically functions in the framework core functions are identify what you got. If you can't protect what you don't know, protect it, detect, right? So that's monitor, respond, and then you have to have a recovery plan, right? And of course, big trick with recovery plans is keeping several issues, because a lot of times if you have these ransomwares, they might be 2 or 3 editions back, right? So here is the maturity levels for the NIST plan, right? And so basically what it is partial means you know what CIS 2.0 is, not much more, right? Risk informed means that you're starting to build plans, you're building it up. Repeatable means we do it, right? And adaptive means it's part of your culture. Okay, you know, I mean, when I started my career, that was a lot of decades ago, safety was, you know, yeah, we did it, and it was kind of a, you know, you give it, what's the word, you just kind of talk about it, but you don't actually live it. I don't think you can go in a facility in at least this province without it being part of the culture, right? It's just taken for granted. We have to get, and that's what this is trying to get, cybersecurity to that same level. Vince and I were talking before the lecture about how in Israel, it is the culture. Because they start teaching cybersecurity in elementary school. It's part of the curriculum. So you wonder why all the cybersecurity expertise is coming out of Israel? Because it's in their blood, right? They've done it from the start. So critical infrastructure regulations, right? A lot of them are American. So, and then there's the European one, right? This is the big one. I'll get to it in a minute. Homeland security. The reason they're important is because they have stuff for the supply chain, especially if you're a critical infrastructure. They can apply to you, right? Security Exchange Commission, they passed a regulation. I didn't write down the number, but you have to disclose an incident within 4 days. It has to be part of your annual report. You have to have a chief security officer, someone that's responsible. Canada, 3 days. We're actually tougher than the Americans on that one. And then there's the US National Security Strategy. This was signed by President, and part of that, this was by President Bush, and it was that zero trust within 10 years for the government. That was it. Anybody that works with the government. This also includes, so they want to go to cloud services. There's an IoT security labeling program, which is kind of funky because they've got a label, but they don't tell you what you need to do to get the label. But anyway, that's the government here to help you, right? A big part of these two is software bill of materials, right? And then the last one is the European Union Cybersecurity Act was passed in 22. Microcontrollers are considered a class 1 device. And so there's a minimum, this is the scariest part, which we were joking about the other day in a meeting. Every time you do a security, so there's a minimum of 5 years after you sell the product that you have to do any patches. So 80% of pretty much any software that you get is open source. So that means that including microcontroller stuff, right? So if that library changes and there's a security patch in that library, potentially you have to provide that because you know there's a vulnerability to fix by this act. And so there's part of the P125 that Vincent mentioned, which is P125 is a committee within CSA that's responsible for the adoption of cybersecurity standards in Canada. Okay. Now, so in our meeting, this was one of the big topics. And because Canadian manufacturers, if you want to sell into Europe, you're going to have to get these certificates. And it takes a lot of bureaucracy, quote, but it would to make sure you can prove, you can self-certify, but in order to prove it, you have to have the infrastructure to collect that data, right? Our joke was, if I need a minimum of 5-year support, does that mean the clock resets when I send you that update? Because then I'm in the infinite cycle, right? So there's No one's figured that out yet, where that is. And then here in Canada, right, we have the bill T26. That's probably coming back again. It's not yet law, but it's being updated. And then we have the Canadian Centre for Cybersecurity. Just some hyperlinks here from the presentation about, so they do this this just came out, cyber threat assessment. There's some pretty interesting statistics. The big thing is that they're moving from banks to critical infrastructure. And I had in the previous slide what critical infrastructure is. So let me just go back. The critical infrastructure includes energy distribution. So that means electricity pipeline, transport of goods. So rail like CN, CP, right? And so those are, when you think about it, right? They don't include water treatment yet, but I'm sure that it's just a matter of time. I think it's just because they know that the water treatment, right, is generally run by utilities. And so they don't have a lot of money to be able to invest, right? The irony is that it makes them an easy target, right? I'm an active librarian, and I was really upset last year when the city of Calgary, right, the library got hacked, and they were so proud because they closed it right away, right? And so they stopped it from spreading. And I'm not surprised that more hackers don't try to come in, because libraries are usually part of the civic infrastructure. Good back door, right? But what really got me is when, was it 8 weeks or 10 weeks before they started bringing it back? And then they bragged about how fast they brought it back.
Yeah.
Fast. If I was a business and I was unable to do my internet for 10 weeks, I wouldn't be a business anymore. Anyway, I'll get off my little soapstick and start talking about 62443. Here it is. This is 62443 in one slide. The main ones are this one, 2.1, on how to establish a program. Terminology is just for concepts, but it's been a long time. It's in the update, but they got over 3,000 comments when they sent it out for first review. So it's taken a bit of a while to get through it. This one's going to be absorbed into this one. The other one that was kind of neat, I was part of this one, was profiles. What a profile is basically saying, if I'm in this industry, these are how I would implement 62443. So they have a requirement that these are the minimum things, and so then once you have a profile, you'll be able to get certified against that profile. So that's why this came. 2.4 is in IACS is Industrial Automation Control System. So think of your control system, right? And so 2.4 is for people that provide control systems. 4.2 is for people that build. So the guys across the road here, Honeywell, this is the one they have to comply to. The one that everybody said typically refers to when they're doing 62443 is this one. Because it's 3.3, because that's the one that the end user needs to comply with. Okay, so what happens a lot of times in a quote, they'll come with the quote and they say, you need to comply with 62443-3-3. I'm going, no, I don't, because I'm this guy, or I'm this guy. So for me to, I can comply with this because this is for my company. It doesn't do you any good for your company unless the good thing is, if I do this, this is the core. And ironic, it's in the middle, but they have in here 7 foundational requirements. We'll show them a little later. And all these other things are based on those foundational requirements. So this is basically the core standard, because it makes sense. If this is the end use, how I'm going to apply it, that all the people or all the other standards need to support being able to meet those requirements. Okay. And so here's the foundational requirements, the 7 of them. no surprise, they look familiar to what you saw for NIST and so forth, right? Identification, access control, right? Roles and responsibilities, change management, oh, big surprise, data confidentiality, right? Encryption, right? Integrity, right? End-to-end integrity. Network segmentation, this is that zones idea, right? Audits, right? Didn't we, right? And backups. Not rocket science. It's the same stuff, but applied in a slightly different way. We have in 62443, they have, instead of the 4 maturity levels, they have 4 security levels. And so basically they tell you how robust you are, right? How likely you are to get hacked or not get hacked. So they have 2 parts. We're engineers, so it's risk-based. So what you do is you do the risk assessment and you come up with a target. So this is the security level target. And then what you do is another group, the engineering group, says, well, based on my design, I think I have a security level calculated. You better be sure that this one is at least equal to that one. Otherwise, you go back and do a recycle and make sure that whatever improvements you have to put in, right? So again, level 1 is, yeah, just an accident, right? I mean, there other people put this about how, and I didn't put it on here, about how good, I guess, a hacker you have to be. So this is the kiddie hacker, right? This would be someone who's got some tools, right? This would be, serious hackers, and this would be a nation state type of scenario, okay? And so, right, intentional violation, someone's targeting you, right? This is sophistication. That's what it means. These guys have a whole suite of tools, right? They're going to not come with just one approach. They'll try to attack from lots of different venues. My analogy is with the library, right? They'll come to the library. They're actually trying to get to the city or NMAX, right? And they're going to come through the city library, something like that, right? And so that's basically what we're trying to do is risk assess. And then you have a maturity level. This is exactly the same as a maturity level that we had, right, for NIST, right? Ad hoc just means, oh, I know what it means. I've heard the word before, right? We're getting processes in place, level 2. Level 3 is we do it. This would be kind of like in the IT world, we have 27001, we get our audits, we get, all that stuff, and we follow it. We don't just, the auditor comes around once a year and everybody practices for when they come around, so we have the right answers. And then 4 is it's repeatable, right? So when people ask you on a bid or something to be security level 4, there's no bloody way you're going to be security level 4, because to get to security level 4, you need to be proven in use for 3 to 5 years. So, right? So the best you can get coming out of a project is 3. And so here's the zones and conduits, right? So this is the Purdue model or the Pura model, right? The functional model for where I'll go into that in a minute. But basically a zone is a collection of entities that represents partitioning of a system on the basis of either functional, logical, or physical relationship. Okay. Conduit is the connection between the groups, communication channels. So it comes from electrical background, right? I have a zone, so I have a junction box. Typically, when they first started, they did this on physical. So I would have all my widgets in this cabinet, needed to talk to all the widgets in this cabinet, and between them I ran a conduit that had all the cables. So same idea, right? So conduit can't go from here to here, right? It could go from BPCS to operation zone. It doesn't have to stop every layer in between. So the The PIRA model is level 0 is the process and associated sensors. So that's what we have down here. Level 1 are the basic controllers. Level 2 is your operator control centers, right? Then you have your operations, which is the higher level. This is higher level control algorithms. Now you have your demilitarized zone, it's 3.5. And then the enterprise, we just lump all the business environment up into enterprise 4. And so this would be one plant, this would be another plant. They may not do them the same. They may not have a safety zone, right? You may break the BPCS zone into for different reasons, right? I might break that into 3 different pieces so that I can isolate, right? If these are parallel trains, I would put them in different zones so that some people put them in the same zone, some would put them in different zones so that I could, if one train goes down, I can keep the other train running, right? If I had to isolate it. But it's all comes back, there's which standards? I know that ISA 84 have come out, they do the safety standards. They've come out with safety and security, and it's a TR, technical report, and it has really good tools to help you come out with the way to figure out zones. So it's a really, really good, strong document. And here's where we go back to what I said, the different, which standards apply from that big grid, right? So if I'm a asset owner, that means I run the plant. Big ones for me are these ones, right? 2324, system integrator, 232433. And here is someone who your DCS supplier, 3341 and 42, right? And so, but like I say, this is the 33 is the common one that everybody kind of relies on. And then how does it go together? Well, this is the other thing with IACS or control systems is the life cycle. Okay, so a typical hydrocarbon facility is at least 30 years. So you're going to have refresh cycles and everything in here, right? So that's the control system upgrade, networks, right? You're adding new capabilities, right? We said what drives it, right? Eventually they'll fail, you know, a lot of, well, let's see, up until, well, I know that when we changed this, like around in 2000 and during the 2000s, most of the controllers that you bought were still running 286 chips. They were based on a 286 processor. So you can't get a 286 anymore. I think now I don't know what they are now, but I know that they went from the 286 to the Pentium as the processor of choice, right? Or the equivalent. But I have this in this facility, then I have it in another one, right? So if you're like a big operator, like any CNRL or any of the oil and gas companies have multiple gas plants or oil facilities, right? That all have this same problem. And so the cybersecurity program needs to run that whole space, right? The information management needs to run to development because the IT program starts before we actually start the design of the operation, right? We got to get the investment in place. We have to build that infrastructure to do all the engineering design and so forth. So the two are related. But we talked all a lot about how we use the same tools, everything else. But IT and OT, like we said, the same goal, right? We want to manage risk. We want reliability, but we look at it from a different perspective. It's like looking in the mirror, right? CIA. IT is all about making sure confidentiality is number one, right? OT, availability is number one because we can't afford to have that processor go down. We can't afford to get it to freeze or hang up or get taken over because now if that pump stops running, that's a coolant that's cooling a reactor and we get a runaway reaction, right? What about in nuclear? right? What happens if you don't get the coolant on a nuclear? It was interesting. I was at a safety conference where there was a speaker from the nuclear industry, and he says, in the nuclear industry, you know, how in every industry, nobody wants to be first. In the nuclear industry, it's the race to third. Nobody wants to be second either. So, but I found this graphic relatively recently, and I thought this is really good to show, you know, it's like the PM, right? You can have 2 out of 3 cost, schedule, or quality. So this is kind of our equivalent, right, for cybersecurity people. So from the cybersecurity perspective, the impact on confidentiality. So confidentiality means preserving restrictions on access and disclosure, including means of protecting personal privacy and proprietary information, right? And so, as we said just now, OT systems, real world processes, if there's a disruption, immediate consequences. The nice thing is that OT, as we saw in that PIRA model, are usually got to dig in pretty deep, right, to get to there. A challenge that we face is legacy field devices. They have no cybersecurity capability. And by legacy field devices, that doesn't mean the sensors. That means those controller levels too, right? They just had no idea of cybersecurity. Modern, if you buy a control system now, a lot of them will come with 62443 certificates against 4.1 or 4.2, right? So, you know, if you lose money, OT, it's the OT data that you're going to lose is might be some secrets on your recipe or how you run a plant, but generally not too big of a thing because everybody kind of runs their plant much the same way. Integrity. So improper information modification. This is a little bit, if you saw that, remember that triangle, a little bit more important for us in IT because we don't want to be running off false data. And it can be, a lot of times we run off false data without being aware of it. Facility I worked at, it was a really kind of dirty service, and we used an orifice plate. So an orifice plate has an impulse line. It's like a tube about the size of my little finger. And in here is a restriction, and and a pressure trap goes across here, right, where my hands are. And what happened is, after the outage, right, we always clean it out every time we have a shutdown. After running about 3 weeks, we changed out the transmitter. We put in an intelligent transmitter. And, you know, we had thought that this was a really great measurement for the previous 20 years that this facility had been running. Then when we put in an intelligent transmitter, we realized after 4 weeks that the self-diagnostics in the transmitter was saying, I'm not feeling well, I'm not working very well. So they went in and they looked, and these little lines, right, they were already 50% plugged. So basically what had happened in the past, after about 3 months, these would be 100% plugged. And so the reading was always nice and steady because it wasn't reading crap. So we were trying to control this process without being able to measure what we were doing to it. So that's why data integrity is important. And I mean, this is how the first OT, well-known OT incident was with Stuxnet. It's like a man in the middle, right? You go in, you get in the middle, and you change, right? They think everything's running great, and you're making it do whatever you want. But as far as they know, everything's still holding the line, right? So this is a potential and something that we're worried about. But the big one is, as we said, availability, right? We need that information now, depending on the application, right? So in a refinery or a process, right, we're relatively slow. We're at about 2 seconds, right? A pump, maybe a little bit faster. But if you look at an assembly line, right, you see the beer bottles or whatever going by. Every one of those needs to know if there's a mouse or whatever in there. So now you're looking at so many per second, right? If you're doing a robot, again, 6-axis control, microsecond control for each direction. So real time is real time. Okay. One of the things about that 5G brought, even though we haven't really implemented it yet, because there's 3 flavors of 5G. We've only implemented the one that's for the you and I, right, with all our phones. But 5G has the capability of basically real-time messaging that with microsecond resolution, or no, millisecond resolution. And ironically, I found this out. Crane operators, that's why a crane operator needs to go with hand signals, because the radio is too slow. You couldn't use a cell phone to talk because there's enough delay that if something happens to the tower or whatever, or too many of us are on there, I wouldn't have that millisecond resolution that's required by regulation for a crane operator. So timing is everything, right? And then, as I said, zero trust, right? So zero trust, they map well onto 62443, right? Strong identities, which is authentication. Zones and conduits, right? Microsegmentation. Zone, right? Zero trust, arguably, is a zone of 1. Least privilege, data flow, right? And so legacy devices cannot do this without an add-on. Okay. OT, right? We focus on safety. Zero trust is about security. But when they collide, what do you pick, right? So basically the whole discussion is, if it comes down to, we can always go like, who's there on first, the culture of security or the culture of safety? And we know that we're always going to pick safety first if push comes to shove. Now, all the standards that are out there, there are several standards about how you reconcile safety and security. And I know I had a big fight with a gentleman from Germany for probably 2 days at a standards meeting, and he wouldn't budge because everybody else in the room except him, we were saying, if it came push to shove, he says, oh no, you got to go. Maybe it's anyway. He would say, no, it has to be done in the risk assessment. I said, your risk assessment does not foresee everything every piece of poop that's going to hit the fan. Gotta go back to the risk assessment. So anyway, I think now finally we found verbiage that he's found acceptable for the standards moving forward. But it was basically saying that if you haven't got it in the risk assessment as an organization, you have to come up with saying, this is what we're going to do at 2 o'clock in the morning on Sunday when something goes south, right? And so what we're saying is 62443, how to build secure OT environments, and zero trust, how to operate them with the mindset of never trust, always verify. And so that's my message. Hopefully we've shown you that the lines between OT and IT continue to blur. You'll learn more about that next week with next week's speaker, and we'll learn even more about cybersecurity in general the rest of the month, right? So the OT standards build upon IT. 62443 is built on 27001, right? 62443 is consistent with best practices. OT and IT, we have the same goals, right? That little triangle, we just look at them slightly different. And zero trust, as I said, is a security zone of 1. So, get any questions, Vincent, or are they coming in now?
No, they've been in.
They've been in. You've been ignoring them?
No, I've not been ignoring. They have not been asking any questions.
Oh, good.
Okay, yeah.
Maybe not so good.
Thank you very much, Ian. I appreciate that. So is there any questions?
Question behind you.
Thanks,
Okay.
Ian. I have a question.
Came with it.
Well, a little bit.
Okay.
Okay, can you share insights on the CSA P125 shaping cybersecurity policy in Canada for critical infrastructure?
Actually,
Because you sit on the board, right?
yeah, so P125.
Can you repeat the question, sir?
Yeah, okay, so question is, how does CSA P125, does it influence policy? Infrastructure policies here in Canada? Standards don't drive policy. So not very, the answer is not very much. What we do have are our members from government, from the Canadian Cyber Center and stuff like that. And so they bring to us, we provide them feedback. So it's kind of a backdoor way. We do through standards try to support the regulations. So we would try to influence the regulation to say, like the bill C-26.
Right.
We would try to say in bill, you would like to put in the bill that they say, okay, to implement cybersecurity, you must have, ISO 27001 or something equivalent. If you're an OT thing, you got to do 62443. I don't think that's going to be in there, but that's typically how standards come into they become policy or law, right? But I think we're not doing a very good job as a whole, certainly from it's the engineers, right? We're too much introverted by and large to influence the government, right? I think too what's going on I think what will influence them and the message we're trying to get up to them is what I mentioned about trade and ANISA. Like if we want to get tighter with Europe, we want to continue to sell into the US where they have tighter cybersecurity rules than us. We're going to have to comply with those rules. So I think that's what's going to wake us up. Once it starts hitting the wallet, even if there's no regulation here, because most companies are now global, they will have to look at the picture and get it kind of through the back door. Right? Yeah.
So there are people online who say thank you.
Oh, okay. Well, thank you for attending, everybody. Yeah.
Yeah. So we're still here. Still have a few more minutes. You can still ask questions if you have any. Let me stop the recording so we can continue.